Hello, everybody. Uh, Welcome to the last topic that we're going to talk about in Building Technology 1, and that is climate. Um, on the Brightspace page, you'll see this as a single PowerPoint. However, I've broken it up into three short lectures just to manage the bandwidth um, of the hardware here. And so I've got three of these for you that covers that one single um, um, PowerPoint. The three topics, right, within climate that we're going to talk about is what is climate and how does climate affect, or why are architects, interior architects, and construction people interested in climate? Why is that even a topic? What is the building industry's role in creating conditions of climate change through activities that create significant CO2 or carbon output? And then lastly, what can designers and construction industry do? What steps can we take to begin to mitigate our contributions, our unfortunate contributions, right, to CO2 output, carbon output, and the subsequent climate change that comes with it? Um, Again, like all the topics we're talking about in this class, you will encounter it again and again through the 7 course sequence. And so this is just initial glance at this topic, which really drives architectural design, whether it's just exterior or interior, and the building industry. Now, it is one of the primary focuses. So, first of all, what is climate? Let's make sure we understand what climate is, and really particularly as it relates to weather. So, climate, right? So here's a basic definition, right, or a description of climate, right? It describes average weather patterns in a region over a long period of time. And so the two pieces to this, one is, right, it's over a region. It's not just one localized area, but a region, and it has to be over a long period of time, often, measured in decades, right? Climate encompasses a number of different climatic conditions: temperature, precipitation, wind, all the things that kind of we've talked about as it relates to site, or many of the things. Temperature and precipitation are significant ones, and they're the most important that we keep an eye on. Because they drive other conditions: snowfall, amount of rain, um, dryness, heat gain from exorbitant temperatures, or increased coldness because of unexpected um, um, climatic conditions. Weather, right, is a different thing. Weather is an aspect of climate, but it's more of a snapshot. Um, and uh, any single weather event, or even multiple weather events over a short period of time, do not indicate conclusively a climate condition. You have to look over a long period of time, over a broad region. Okay. And so that's really kind of an important distinction, right, that we understand. So we're talking about climate here. So, like so many other things that we deal with, is that we um, um, chart the our country to begin to understand how climate operates in within the northern hemisphere, and and so we have identified, right, environmental scientists and those types of folks, right? They've identified climate zones, and those climate zones have various characteristics. And there's basically 8 of them, and they categorize temperature and humidity. Topography can have some impact on those climates, and so in a more mountainous area that might be in the same climate zone as someplace that has more flat and level terrain, there can be some variation. But generally speaking, the climatic conditions hold, generally speaking. And then there can be some unique other unique geographic conditions that can affect a climate zone, um, prevailing winds, um, particularly those kind of created by ocean currents, and can affect climate regions, particularly in coastal areas. You probably remember from your high school environmental science classes, that even though Europe is on the same latitude as the northern part of the United States, Rome is on the same latitude as New York, and therefore Britain is much higher. It's on a higher latitude, that the temperatures in Europe are generally much warmer in the higher latitudes than in the United States, because of the jet stream of water that comes out of the Gulf and moves its way up the Atlantic along the eastern coast of the ocean. So on the eastern side of the ocean. Yep, eastern side of the ocean. And that brings warmer waters and therefore warmer air that then affects the climate. So the climate in northern Europe is very different than the climate at the same latitude in Canada, right? So these things that can kind of affect it. So we have 8 climate zones. This is the map of climate zones. And when you're doing a building that is going to really have a heightened sense of how it's going to utilize the natural environment to um, um, to create a building that has reduced energy use, you need to know what climatic zone you're in and the conditions that exist within it. Again, at some other point, you'll get more deeply into those, what really is included in that. We're not going to talk about that now. It's a little too deep in the weeds for an introductory class, but it's important that you know that there are climate zones and throughout the United States, and they're an important thing to understand before you really start digging into the design of your building, at least the technical aspects of your building. So why do we care about climate? Well, we as designers and people involved in the building industry utilize the conditions, natural conditions, as we've described through the last few lectures, to do certain things for us in design work. And the stability of the climate is crucial in making decisions about how we design buildings, what type of technology we have in them to make sure that they are providing us with the type of climatic comfort on the interior in relationship to the uncomfortable climatic conditions on the exterior. And so climate for us, when we're doing a design, affects the orientation of a building, the predictability of the sun, knowing that it's always going to be in the southern hemisphere, tells us that we know certain types of windows, right? We might want a lot of windows on the south facade to get a lot of sun in. The north facade is only going to get reflected light. It's not going to get direct light. So we have other types of windows there. Things like that. It's going to affect the envelope. If you are in a very dry climate, you're going to want certain aspects of your building envelope, which would be very different from a very wet, humid climate. Okay? It will affect the type of environmental control systems that you have, your air conditioning systems, your dehumidification systems. It affects structure and material. That a masonry building does not do well in a hot, humid climate, right? And so you're not going to use that. You're going to use a stick frame construction because you want something that's lighter frame that doesn't hold heat in a way. In a hot, dry climate that might see significant temperature swings. Let's say if you're in New Mexico, right, where it gets very hot during the day, but cold at night. Yeah, a thick masonry building can work for you. But if you're in a hot, wet climate, that's just not going to be the case, right? And then site design, how you fashion the site to control where water moves through your site and how it runs off a piece of property, or it can be kept on a piece of property for particular purposes. So the amount of rainfall that we get and things like that. Those are all things that we use when we design buildings. And so we want to know what those are like in those climate zones, right? So let's kind of get into a little bit more about what climate kind of impacts, right? So the choice of materials varies depending on climate. The types of forms that your buildings take, in the deep south where it's hot and humid, buildings were long and thin. And they're long and thin. Let me get out of the way of my own drawing. Long and thin because they want to have cross ventilation through the building because it's hot there and there wasn't always air conditioning, right? So in old traditional buildings, you see long and narrow things. In the northeastern part of the United States, throughout the northwestern part of the United States, buildings were square because with a central heat source right in the middle, the chimney. And that was so that there was an equidistant distance from that heat source to the perimeter, right? And that perimeter, right, was consistent. The heat was not going to migrate one way or the other, right? It was going to sit in that space, right? And so the very shape of buildings, just the basic form of them, is affected by that. Scale and orientation are another two. Scale has to do with just the size of your buildings. In certain climates, it's going to affect that. And so when they start building more sophisticated buildings in the South, before there was a lot of significant use of energy, you would have it. Let me just kind of get it out of my way. Okay, it doesn't want to. You're not going to make a massive building. You get multiple small buildings, right? Or multiple buildings shaped like that. Whereas again, in a different climate, you would get a much larger flat building, right? And then orientation, depending on where you are in the continental United States, moving from north to south really affects how you want to approach the use of the sun in your design. In the deep south, throughout also Texas and Mexico and into Arizona, the sun is not always your friend, right? And so you really want to be careful of how it enters into your building, what kind of shading opportunities you're giving outside your building. Whereas in the Northeast or throughout the northern part of the United States, sun is a welcome thing because there's a lot of days where it's cold out. And so we want that heat gain. And so where you are will affect how you orient your building to the south where the sun is, right? Climate impacts wind, and we've already talked about wind a lot in another lecture, but understanding the way the prevailing winds come will affect it. The fact that wind moves in particular ways lets us create passive solar opportunities, and all these other things that we've kind of already covered. So wind is part of climate. Precipitation is as well. And we've kind of talked about that in different places, right? The slopes of roofs are very different depending on where you are in the United States and how much rain it gets or how much snow it gets. There's places in the United States that get just so much rain, they don't even bother with gutters, right? They make sure their roof has a certain slope to it. And then there's a very deep eave that sheds the water, right? And deflects it from the building instead of trying to drain it away from the building, right? Of course, with that comes significant weight. Very wet snow in cold, humid climates can put incredible weight on a building, and we have to know that is a potential condition. And so when we structure our buildings, that's the case. And then the materials, right, that we want them to be able to withstand the precipitation conditions that affect the building, and particularly even the penetration of that first layer of an envelope system, and how that type of humidity could get into a building envelope or within a building, create mold conditions, deteriorate materials, and cause failure within buildings. Excuse me. And then, of course, temperature. That's really a big one for us. And that really impacts, the envelope and the thermal efficiency of buildings. And so understanding, having an understanding of a consistent climatic condition of temperature within a climate zone, right, helps us plan for heating, cooling loads, that we know that in this climate, the hottest it ever gets, right, on average, is 86 degrees. The coldest it ever gets is 32. And that tells us the type of work the building is going to do, the building envelope and the mechanical and passive systems that we have, to make the interior have the type of climatic conditions, right, that separate it from the exterior climatic conditions. We have to remember that outside is generally not comfortable for us, right? We need an inside. We need it to be less humid. We want it to be relatively cool, and for us to be comfortable. And that's very different typically from what's outside. And so what kind of insulation we'd be using, how much we need, should be using more thicker building structure material for more thermal mass. Those are the things that get affected by temperature. So that's what I have for this little piece. We're going to move on now in our next video, to another piece that I've got set up for us. Okay, thanks.